All right, algebra 2. So I showed you this in class where what you want to do with this equation, again, we're solving exponential equations, is we want the bases to be the same. And excuse me for my voice if I'm having a little trouble understanding. If basically we change the 8 to 2 to the cubed, or 2 cubed, and then we multiply the exponents. And then because the bases are the same, that means that the exponents have to be equivalent as well. So we can just set those equal to each other and then solve for x. Now, in this case, we could try and make the bases the same for 200, but I can't. 200 is not 5 is not a root of 200. So there's no way I can make that the same base. So what we do here in this case is we're going to use the logarithm and log both sides. So basically we take log here and then log of 200. So if I rewrite it looks like this. 5 to the x minus 2 and then log of 200. Okay, so we're going to use this to solve. So we want to use our properties that we know. Now, first of all, I know that I've got x minus 2 here. So I can use the power property and bring that right to the front. So now it's x minus 2 times log 5 is equal to 200. Now, I want to isolate x and get it by itself. So let's get rid of this log on this side. Divide it from here on both sides. That cancels out the log. And now what I have up here is x minus 2 is equal to log of 200 over log of 5. Okay, and so now the last thing I want to do is add 2 to both sides. So I add 2 to both sides. And then I end up with this, log of 200 over log 5 plus 2. And if I evaluate that, then I get my actual value. So I'm going to pull out the calculator real quick and pull out the logs. So we go control log. Again, if you don't put anything for the base, it just automatically assumes you're doing 10, and it's log base 10 here anyways. So 200, and all this divided by the log of 5. Oops, sorry, I don't want the base there. Okay, and then plus 2. Okay, and you can double check to make sure you did it correctly. You can look at this, and so you can notice that it put 10 for the base. So then our answer is we'll round to the nearest hundredth, 5.29. Okay, all right, so now down here, same thing. Here, I see 3 and I see 27. Now, 3 is a root of 27, so I can change the base here and make this 3 to the 3. Now that the bases are the same, that means the exponents have to be equivalent. So 2x, so I bring these down. 2x is equal to 3, and just divide both sides. X is equal to 3 over 2. Okay, if you notice here, again, I have 7, and I can't make, 7 is not a root of 21, so I'll log both sides. Oops, sorry, I forgot the log. Okay, and again, I can use the power rule, bring that down into the front. So now it's negative x times, remember it's multiplication there, log of 20 equals log of 21. Divide both sides by log 7. That's gone. Now it's negative x equals log 21 over log 7. But then again, I've got this negative here, so I've got to divide that out. So I got a negative 1, divide that. And if I divide, that means it just goes down here in the denominator here. But again, it doesn't really matter. It's just whatever this value is equal to, it just becomes negative. Okay, so now I'm going to put that in the calculator. Again, same thing, log 21. Oops, sorry, I don't want that to be the base. 21 divided by log 7. Again, I keep putting in the base. And then it's the same thing, just negative. I just didn't put the negative in there. Actually, I'll show you how to put the negative in there if you're interested. So I just put negative 1 right here. And I'll get the same thing, negative 1.56. Or if I round that, oh yeah, so the 4 doesn't make that go up. So we'll say x equals negative 1.56. Okay. All right, so now this one, Again, we can't make the bases the same. So log 4 to the x minus 1 and log 5. Okay, you guys go ahead and solve that and pause here to see if you can figure it out yourself. All right, so after I worked through that problem, boom, I should have got 2.16 here. Again, I just used the calculator to do the final steps there. Use the power rule, bring that down, divide both sides by log, then add the 1 to isolate the x. Okay, go ahead and do the same thing with this one. See if you could try to figure this one out on your own. Okay, go for it. All right, so now, if you remember, if I've got this a number over or under 1, I can rewrite this as 27 to the negative 1. That's the same thing. But again, I have that same exponent of x minus 5 equals 27. Now these are the same base, so this kind of works out. But remember, the exponent here is just a 1. Okay, so now what I have to do with these exponents is that I have to multiply them, which means I have to distribute this negative 1 to that binomial there in the top. So now it's 27, negative 1 times x, negative 1 times negative 6, positive 6. So now it's 27 to the 1. So now the bases are the same, and I can just set the exponents equal to each other. So negative x plus 6 is equal to 1. And now subtract the 6, both sides. It's gone. Negative x is equal to negative 5. Divide both sides by negative 1. I get positive 5. Okay? All right, flip to the next page. Okay, now in all these examples here with these equations, you want to use these different properties that we learned in order to solve them. Okay, so first I've got this log plus this log. So if I see plus, that means I'm going to multiply the a's of each of these. So it's going to be the 80 times 51.2. So log base 8 of 80 times 51.2. Pull out the calculator, and let's see. Okay, so I'm going to do 80 times 51.2, 4,096. So now log base 8 of 4,096. And I can actually just input this right into the calculator. So now I do log base 8, 4,096. Oh, it looks like 8 to the 4. 8 to the 4 is equal to that. Okay, or gives me 4,096. Okay, so then same thing here. I can change this, and then this becomes division, because remember, if it's minus, then it's division on the inside there. Then it's the 128 over the 8. Okay, and then 128 divided by 8. It's going to be 16. So it's log base 4 of 16. And I know that 4 to the 2 is 16. So then it has to be 2. Okay, and again, here, use the power property. Okay, boom, bring that down. Bring to the front. So 5 times log base 2 of 16. I know that 2 to the 4 is 16, so this is 5 times 4, which is 20. Okay, so we want to use these ideas as we solve these. Okay, so now this one here, again, let's use the change of base formula. Okay, so I know that 3 to the 2, it will be equal to x minus 5. And then it's a simple linear problem, linear equation. 3 squared, 9. Add 5 to both sides. X equals 14. Okay. Did you get the idea? Okay, now here I've got 2 logs that are the same base, and that's one key thing you need to remember. We can only use these quotient and product properties as long as the bases are the same. I need to emphasize that. If this was like log base 8 and log base 7, you couldn't put those together. Okay, so they have to be the same. In this case, there's none, so they're both 10. So now it's log base 10, 45x over 3 is equal to 1. Well, let's simplify that. That becomes 15x equal to 1. Now remember that base has to always be 10. So now it's 10 to the 1 is equal to 15x. And I just go ahead and divide 15, and simplify that. Divide both of those by 5, and I'll get 2 over 3. Okay, just reduce the fraction there. Okay, so now this one, I noticed that I've got an exponent. So if I have an exponent and bring that to the front, so it's 2 times log base 4 of x is equal to 7. Now, as I'm looking at this, I'm like, okay, well, now what do I do with that? Can I simplify this? How? Okay, so that didn't work. So now I got to try a different rule. So I'm going to say, okay, well, let's try the change base formula. Okay, so not change base formula. Let's just use the property that we can change this in exponential form. So we're going to put 4 to the 7th is equal to x squared. Okay, now I'm like, oh, wait a minute. X squared, I can just square root both sides. Okay, so that goes away. And now the index is 2. I've got 4. I have 7 4s here, because remember, this is 4 to the 7th. So that means that 3 will come out, and I'll still have 1 inside. But now, remember, this is an even root, so I have to account for plus and minus values, okay, in this case. So now, this could be 64, and square root of 4 is just 2. So then 64 times 2, x is equal to 128. Okay. Now this one here, again, I've got that plus right there in the middle, so that kind of keys me to think, okay, let's try the product property. Say we'll do x log of x times x plus 9 is equal to 1. Okay, we'll distribute that x there. X squared plus 9x equal to 1. Okay. Now I can use again the formula where I can change this, where it's the log base 10. Okay, always remember that's a 10 right there. To the 1 is equal to x squared plus 9x. And now if you remember, if we've got 3 different types of terms, we've got an x term, an x squared term, and a constant, then we want to make it equal to 0. Okay. So now it's equal to 0, and now we want to factor this. Okay. So I say, okay, well, it's got to be x, I'll have a 10, a 1, plus 10 and minus 1. Because 10 minus 1 gives me 9, negative 10 times 10 gives me that. So then our answer will be 1 and negative 10. Now you might be thinking, well, wait a minute, when we did rationals and radicals, we always had to check our answer. Well, guess what? It's the same thing here. We need to plug both these values back in and check that. So I'm going to pull up my calculator here and just make sure that we're good. So I'm going to go ahead and plug that 1 in there. So we're going to have log base 10 of 1 plus log base 10 of 1 plus 9. And I'm going to set that all equal to 1. Okay, that's true. So this one works. But now let's check this one. Again, I'm just going to copy this one and edit it. So here I'll put a negative 10 instead. And there, do the same thing. And look, I get this says non-real calculation. Doesn't work. So that means that this one is no good. There's only one solution there. Okay, so we have to do this as we go through. Okay, I want you guys to try this one and this one. Try it out on your own.